Welcome to Project Lead the Way's Principles of Engineering course. Throughout this course, I will be talking about engineering and engineering technologies that are found throughout the world. Throughout the videos and subsequent videos, I will be referring to this course as POE. POE just is an acronym for Principles of Engineering. Now, before we start, we must talk about careers within engineering and engineering technology. But the first thing that we're going to talk about is what is engineering, followed by what's the differences between engineering and engineering technology, what is ABET, and finally the various different disciplines of engineering. So what is engineering? Engineering is the use of math and science to solve practical problems. It requires creativity, persistence, and a desire for improvement. You have to be able to build and improve upon a project. Now, the differences between engineering and engineering technology is that engineering requires more mathematics, while engineering technologies require less so. Engineers are going to be more on the research. They're going to be complex analysis. They're going to be complex design. They're also going to be developing. So this is the design phase of making something. On the other hand, engineering technology and engineering start to overlap when it comes to the actual building of the items and testing and evaluating of those items. Now, engineering technology doesn't necessarily mean that they're worse or better than engineering. They're different. They do different tasks. Engineering technology are the people on the floor building the devices, testing them. They also could be putting into routine designs and productions. They could even be in operation and service and maintenance. They can even be so far away as being the sales and distribution individuals. All of these people are needed in a business building whatever they need to build. ABET is also an organization that is referred to as the Accreditation Board for Engineering and Technology. What they do is they go around to different colleges and universities and look at their science, computers, engineering, and other technology courses and making sure that they are up to standard. If they are, they get passed and they're ABET certified. If not, they cannot give you a diploma in that particular degree. Now, if you're afraid that your particular university is not ABET certified, you can always check their website at abet.org. Most universities, such as U of U, BYU, USU, Weber, and all the other major universities in Utah, are all accredited and don't have to worry about it. Now we're going to talk about the bulk of this information, which is the engineering disciplines. U.S. government keeps track of 17 different engineering disciplines. Now, ABET accredits those universities for that. And so there are subfields within them, but these are the 17 major engineering disciplines: aerospace, agricultural, biomedical, chemical, civil, computer, hardware, electrical, electronic, environmental, health and safety, industrial, marine, ocean, material, mechanical, mining, and geological, nuclear, and finally petroleum. Aerospace engineering is testing and making aircrafts that go through either the air or through space, i.e. rockets, uh, helicopters, planes, gliders, uh, spaceships. So that is aerospace. Agricultural is engineering of farming and ranching. They're going to be doing irrigations or mechanized farming. Biomedical, these are devices that are used in medical conditions, such as the heart monitors. They're going to be talking about artificial limbs or organs. A picture shows you a valve to a heart. Chemical engineers are people who produce and create different chemicals on a mass scale, such as creating the next Kevlar for bulletproof vests or a new hydrogen fuel cell for the new cars. Civil engineers are those who maintain and build structures that do not move. So bridges, dams, roads, tunnels, even the actual support structures of the roller coaster. Computer hardware engineers are the people who build and create the hardware, the physical items of an actual computer components, such as the mice, touch screens, the virtual reality goggles. Electrical engineering are those who develop, design, and create electrical systems such on a large scale, such as large power plants. And they can even be used on a smaller scale, like the power from your computer to your computer screen. And they can go from anywhere from a car to an aircraft to a whole city to as small as your cell phone. Electronic engineering, on the other hand, are those looking at the small components within an actual appliance or device, such as a cell phone or a smartphone. They're looking at the different kind of little components within it, how to make it better, building video games or the actual uh, consoles themselves. Environmental engineers are those that are going to be dealing with like recycling and water reclamation or water treatment. Health and safety are those who are going to look at the potential work hazards and how to prevent accidents and anything else that might cause dangerous situations. Industrial engineers are those who work in a warehouse or a industrial facility where they're going to create something on a mass scale. They don't necessarily make it, they design it, they make it on a mass scale. So can you create in many cars as humanly possible, as fast as possible? And they can build it go as big as airplanes down to as small as diapers. They do everything. Marine and ocean engineering are those who build boats or submarines or oil rigs, anything that deals with the ocean or water. Material engineers are going to be those who are building new and cool, specifically designed purpose materials, such as like artificial skin for a burn victim, the next coolest Kevlar, maybe a self-healing polymer. Mechanical engineers are the largest of these groups. These are ones that do research and development and build anything that moves. These are the largest field of engineering and the most sought after currently. They're going to build like power turbines, cars. They can do anything that moves. Mining and geological engineering are those who go into mines and how to extract ores and minerals from the earth using explosives or other drills, and how to take that material and then transport that and then process that material into their final product. Nuclear engineers are those who are going to develop methods and systems to use nuclear fuel, either in the form of a nuclear power plant, nuclear subs, or even in medicine with nuclear medicine. Petroleum engineering are those that go out, find, extract, and then transfer natural gas, oil in a form in other various places throughout the world. If you have any further questions, please ask your teacher.